Hi, I am Mali. Welcome to the channel. From pitch blacks to bright whites, the CosXL model is an experimental take on the Stable Diffusion XL model by Stability AI. It offers rich tonality, good consistency, and impressive overall details. Using the CosXL edit with InstructPix2Pix, you can create consistent variations and image edits with just prompting. The edits are impressive. And that too without the use of any control net or adapters. You can also get creative edits with non-AI generated images like this actual photo. Today's tutorial focuses on the CosXL and CosXL edit workflows, a unique upscaling method, advanced model merging, and some of my hacks and tricks in ComfyUI. Firstly, I would like to thank all the paid channel members for supporting the channel. Also, we just crossed 10,000 subs, so thank you for that. CosXL is a new model released by Stability AI for research purposes only. This model is tuned on the cosine continuous EDM predicted variance schedule. It controls the amount of noise added or removed at each step of image generation using a continuous cosine function. The benefit is that the model can capture a broader spectrum of colors, including true blacks and pure whites. The second part of this model is CosXL Edit, which is based on InstructPix2Pix. Now, Pix2Pix refers to a general class of deep learning models that can translate one type of image into another. Instruct implies that the Pix2Pix model in CosXL Edit can take instructions through text prompts. This is not a basic tutorial. I use some techniques that require comfy know-how along with control net usage. Also note that there is a learning curve for getting good output results using CosXL and CosXL Edit. So please watch the tutorial, as the dual CFG guider, K-sampler, and basic scheduler values have to be changed constantly depending on the prompt and desired output. I will also showcase a new upscaling technique never shown before on the channel using Ultimate SD Upscale. And the last part of the tutorial will focus on how to convert any checkpoint into a CosXL checkpoint via advanced merging. The switch and integer nodes from the impact pack are used in the workflow. Control net is required for upscaling. The workflow will also use latent and ultimate SD upscale. Some utility nodes from the ComfyUI Studio are also required. SDXL prompt styler is needed for the CosXL edit workflow, and I use the float node from Comfy Logic to edit values in the advanced merger workflow. Lastly, many RG3 nodes are used for workflow optimization and ease of use. Please note that these are gated models, and you need to fill in your details before access is granted. You need to download the CosXL and CosXL edit models from Hugging Face. They go into the models checkpoint folder. I am also using the TT Planets Tile Control Net model, which is available from Civit AI. The page links will be in the description below. I will start with the basic CosXL workflow and then move on from there. Add a load checkpoint and a self-attention guidance node. This node is now basic and should be included in all workflows. It just gives better and more detailed outputs. Make the connection and add a LoRa stack loader node. Connect the model and the clip. Since CosXL is similar to the base SDXL model, you get better results connecting it with an SDXL clip conditioning. Convert both the text G and L widgets to inputs and connect them with a primitive node. This will be the positive conditioning. Duplicate both the nodes for the negative. Make the clip connection. For CosXL, it's advisable to connect with the custom sampler advance rather than the standard K-sampler. I am going to drag out each input and connect the relevant nodes. First, the random noise. This is the seed from the case sampler. Convert the noise seed widget to input. Connect it with the seed node from RG3. The dual CFG is basically used for the InstructPix2Pix in the CosXL edit. I am including it for CosXL because it gives finer details. The CFG conditioning value works like your normal CFG. Conditioning 2 and negative are both negative, and changing this value in the CosXL edit has a drastic effect on the output. However, for the CosXL model, if you keep this value at 0 or 100, there will be no change in the output. For CosXL, you only need to change the CFG conditioning. It works like your normal CFG. Later on, I will show you a comparison of the output with single CFG and dual CFG guider. Connect the LoRa output model with the dual CFG, the positive to conditioning 1, and the negative to both, the conditioning 2 and the negative inputs. I am changing this value to 3 as that's the default for CosXL edit. We need to duplicate these nodes for the edit workflow. Again, this value has 0 effect on CosXL text generations. Add the case sampler select node. I prefer to use the DPM++2 MSDE sampler, which I will use for the tutorial. The sigma is the basic scheduler and includes the number of steps as well. For CosXL, I will stick to Keras with 40 steps, and the denoise value should be 1. Connect the scheduler with the LoRa model output. For the latent input, I will use a more convenient SDXL empty latent node from RG3. Connect the sampler output to the standard VAE decode node along with the preview and save. This completes the single-pass CosXL workflow. Put in a positive and negative prompt, and let's hit the Q prompt. Mind you that the tone color range is very wide. Get creative with the prompts to get beautiful color tones. For the base CosXL, don't use too many negative embeddings. Put all these nodes under a single group called CosXL base. Arrange and color code the nodes as desired. For the workflow, we need this group to be on and off with a click. For that, add a fast muter group node from RG3. Right-click and go to Properties. Rename the title, change the color if needed, and type in the group name CosXL base in the Match Title field. We can disable and enable this group when required. This is not part of the workflow, but I want to show you why a dual CFG node was used for the CosXL base. I am going to duplicate the sampler and reconnect everything except the guider. Adding a comparer node for comparing the outputs. Drag out the input and connect it with a CFG guider node. Make the connections and hit the Q prompt. The image coming from the right is from the dual CFG. Let's zoom in, and you can see it's more refined. You can even see the details and clarity in the bokeh background. To refine the image, you can process it via a second sampler pass, and while at it, we can also do a 1.5x latent upscale. Duplicate these nodes and put them above the base group. Drag out the advanced custom sampler output and add a latent upscale by node. Change the upscale method to BSLRP. BSLRP stands for Slightly Better Latent Upscaling with Spherical Linear Interpolation. Basically, it is an advanced version of SLRP offering better interpolation and is better than nearest exact. Connect the latent upscale with the custom sampler. Here, ensure the denoise value is less than 1. I have done a lot of testing on CosXL and the merged RealVis XL checkpoint. A good range would be somewhere between 0.6 to 0.7. Also note that the sampler selected should be the same for both passes. Typically, keep the scheduler the same as well, however, you may get undesired results in CosXL. Whenever the second pass changes the images a lot, select exponential as a second choice for the sampler. Then, go with SGM uniform or normal as a third choice. How much the image changes is dependent on the prompt. Lastly, ensure that the number of steps is the same as in the first pass. Organize these nodes in a group called CosXL Refine. The second pass is way better and upscaled as well, but you can clearly see the changes. The face is the same, but the structure is slightly different. It fixed the neck and the eyes. Play around with other schedulers to get some creative results. Before we connect this to the pixel upscale, let's ensure that this group can be enabled and disabled as well. Right-click the RG3 node we created earlier. In the Properties panel, change the Match tiles to include the new group CosXL Refine. Sort by should be custom alphabet. And type in the following. This allows us to use or skip the second pass. The next step is adding and connecting the ultimate SD upscale with both outputs. I am going to add a switch from the impact pack. This will allow you to switch and choose the raw or refined output for upscale. Connect the base VAE output first. Then, connect the output from the refined VAE to input 2. Rename the node and the input as shown. Add an upscale using model node. Connect it with the switch and the upscale model loader node. The 4x foolhardy Ramakri does a pretty good job here. I will leave the Hugging Face link in the description below. This is going to do an image-to-image upscale by 4x. This won't be that good. The point of doing this is that it will help add some minor pixels, so when we put it through Ultimate SD Upscale, it's still better than without this process. Since we used a 4x model, we need to downscale the image back to the original resolution. So, add an image upscale by node. Change the upscale method to lengthsos, and the scale by value would be 0.25. This will downscale it by 4x. Now add the Ultimate SD Upscale node and connect it with the downscaled output. Connect the model as well. Ensure you are connecting with the LoRa output. Now, add a standard control net node here. Connect the positive conditioning to the control net. Ensure that you connect the non-upscaled image output with the control net. Now connect the control net loader and select version 2 of the tile control net model. We only need the positive conditioning to pass through the control net. connect the upscale model, negative conditioning, and the VAE. Right-click and convert the seed to input. Then, connect it with the RG3 seed node. Convert the tile width and height to inputs as well. This will then connect to an integer node from the impact pact. Rename the node to tile size. I am using this on a 4090 with a pretty hefty overall system. Anything lower than this resolution will reduce quality. The higher, the better. This upscale is not optimized for speed but instead designed for quality. So use this value only if you have a 24 GB VRAM or higher. If low on VRAM, stick to lower resolutions as per your GPU. You can go as low as 512. I am going to upscale this at 4x. If you want quicker generations, keep this value at 2x. Keep the CFG at 7 and change the sampler and scheduler as shown. Keep the denoising value at 0.3. We want the upscaler to add some details. Here is an image generated using a denoise value of 0.3. CosXL uses a wide range of color tones. Since we are using a tile-based upscale, sometimes this causes a color disconnect between the tiles, resulting in color banding and oversaturation across the image. You can avoid this by reducing the denoise to 0.10. However, I would not recommend this unless you get this issue. Change the seam fix mode to half tile plus intersections, and let all the other settings remain default. Duplicate and connect the image upscale by node. We want to reduce this 4x upscale by 2x for a sharper output. Change the value to 0.5. If you are using a 2x upscale and Ultimate SD upscale, bypass this node. Organize and group these nodes. Rename the group to base upscale. This will allow us to pass on any one output to CosXL edit. Duplicate the RG3 node and place it in a convenient location. Rename the node to CosXL upscale. Then, go to the properties and make the appropriate changes to include only the upscale group. So, let's summarize the organization. You first enable only the CosXL base and run the Q prompt. Then, enable the refine group, change the settings, and hit the Q prompt again. You can fine-tune the refine or proceed with the upscale. Enable the base upscale, choose raw or refined, and then hit the Q prompt. Note that at these settings, the upscale takes about 1050 seconds on average, or about 17.5 minutes. As I said earlier, the upscale is designed for quality, not speed. Skipping the refining process, using 2x upscale, and a smaller tile size will all reduce the time drastically. This upscaling method is slow but stable. It uses about 70% of the 24 GB VRAM and around 50 to 60% of the 64 GB system RAM. Let me show you a couple more examples. All these have gone through the latent refinement and then the SD upscale. You can see the color tones and range this model can produce, and the upscale quality. In most of the images, I can get these deep blacks. If you are watching this on an OLED, you will be completely blown away by the blacks and contrast. And have a look at the brush details. Looks like a DSLR photo rather than AI generated. These have zero post-processing and are exported at just the 8-bit PNG. Add a switch from the impact pack. This gives the flexibility to choose the raw, refined, or upscale output image. Connect the switch with each of the outputs. Rename the node and the inputs as per the connections. Connect this with the image scale to total pixels node. Change the upscale method to lengths. This node will resize the image to 1 megapixels. The reason for putting this is that the CosXL edit will work with near SDXL resolution only, mostly 1024. So you may ask, why connect the upscale? Even though the image would be the same, you will get a different output because we upscale at a denoise value of 0.3. Some new pixel data is always added. Secondly, you may want a sharper image for CosXL edit. The switch takes care of the output from CosXL base. However, for CosXL edit you can also load a custom image. Add a load image node and connect it with another image scale to total pixels. Now add another switch that connects to both these inputs. Rename the node and inputs as shown. Now copy and duplicate everything from the CosXL base group. Change the checkpoint to CosXL edit and delete the positive and negative primitive nodes. Now, I will add a text prompt switcher from the ComfyUI Studio. This will allow easy switching between a custom prompt and SDXL prompt styler. This will be the positive switch. Connect the string to both G and L inputs. Rename the switch inputs and the node as shown. Duplicate, connect, and rename to negative. Add the SDXL prompt styler and connect with the positive and negative. Now add a ComfyUI text node and connect it with the positive. Then, duplicate it and connect it with the negative. Rename the node's title to indicate the positive and negative. Convert the positive and negative switch input selection widgets to inputs. Connect these with an integer node from the impact pack. Here, the value can be 1 or 2. Anything higher than 2 will be considered as 2. Change the node title to reflect the same. You can select one for the custom prompt and two for the SDXL prompt styler. Add the InstructPix2Pix node between the conditioning and dual CFG guider. Connect the positive and the negative. For the output, connect the positive to conditioning 1 and the negative to conditioning 2. The negative should come directly from the clip text encode and not the InstructPix2Pix output. The latent will connect with the sampler latent image input. Connect the image input switch as shown. Also connect the VAE. Delete both the preview images and add an image compare node. Connect the VAE decode to image A and the image input switch node to image B. Color and organize the nodes into a group. Name this group CosXL Edit. We should add this group to the previously created CosXL on and off node. Right-click, go to Properties, and add the group name in Match Title. Duplicate and place a copy at a convenient location below the CosXL Edit group. Let me explain the parameters as dual CFG works differently with the edit model. First, select the correct output image. Then the correct input image. Let's try a positive prompt. I want to edit the image to show the character in gothic makeup with a Harley Quinn style face tattoo. I won't use any negative prompts for this one. You can even go with very simple prompts, like if you want to change the lighting of a scene from day to night, just put night in the positive or day in the negative. Ensure that the prompt switch value is correct. The default dual CFG values are 5 for the conditioning and 1.5 for the negative. They are correlated. I'll explain with a live example. The only good samplers I recommend for the edit are ancestral ones. So try the Euler, DPM2, and the ++2S ancestral ones. These are the most effective with the edit model. For the scheduler, all of them can be used in combination for creative results. I recommend trying exponential and uniform as they also yield good results than the standard Keras. Keep the steps at 20, as it is way more sensitive with the edit model. Make increments at 5 to get very different results. Higher is not always better here. Denoise will always be at 1. Let's try and see what we get at these settings. The edit is extremely strong here. If you increase the CFG conditioning, the edit will get stronger. If you reduce the value, the edit becomes weaker, and the image will be closer to the original. As per my testing for facial edits, a value of 2 to 3 would suffice. For other edits, you can go as high as 8. The conditioning 2 and negative value works in reverse. Increasing this value will weaken the edit, and decreasing it will make it stronger. And this is way more sensitive than conditioning. Let's reduce the value from 5 to 2.6. Way better. Let's have a closer look. Okay, so this is amazing, and believe me, it's impossible without a CosXL edit. I have tested so many edit generations with this model, and the way it maintains consistency amazes me every time. This level of editing takes days in Photoshop. Let's try the SDXL prompt styler with this same image. You can, of course, put additional positive and negative prompts, but I will leave it blank for now. Let's try a different value and scheduler. I picked a face to showcase the level of consistency. Without knowing the proper settings, you will get inconsistent results. Faces are hard, so if the face changes, remember to reduce the CFG value close to 2. Now, let's try a non-AI image. This is a photo taken in Iceland. Switch the input for the custom image. Changing the prompt. And this time I will put in a negative prompt as well. Ensure that the prompt switch is set on custom. I will go with the default value since this is a landscape and will increase the steps to 25. You can see I have made quite a drastic change, and even for a non-CosXL image, it maintains consistency very well. It completely replaced the background for the clouds, and even extended the road. Latent upscale with CosXL edit doesn't make any sense. It's a hit or miss, and the image changes a lot. So, it's not workable for non-AI images. Even for images generated with CosXL, somehow, the model does not perform well. I only recommend using the Ultimate SD Upscale. Copy all the nodes from the base upscale group except for the switch. Paste the nodes below the CosXL edit workflow, right at the end. Connect the VAE decode with the upscale by model node and the control net. Duplicate the compare node and connect image A with the newly copied image downscale output. Organize the upscale nodes in a group. Rename this group to Edit Upscale. Now go to the CosXL Update Enable and Disable node, and add the Edit Upscale group. This gives the flexibility to disable the Edit Upscale if not required. With advanced model merging, we can convert any checkpoint to a CosXL checkpoint. This means you will get all the fine-tuned properties of the third-party checkpoint with the color tone, depth, and range of CosXL. Add 3 load checkpoint nodes. The first should be CosXL. The second would be base SDXL, and the third would be your third-party fine-tuned checkpoint. Real vis XL in this case. This is how it works. we take CosXL and subtract the SDXL base from it. This leaves us with only CosXL without the base SDXL. Then, we take RealVisXL and add it to the CosXL. We will do this for the model and clip both, the model requiring some extra nodes. Search and add the clip merge subtract node. CosXL clip goes to clip 1, SDXL goes to clip 2. Now add the clip merge add node. Output from subtract goes to clip 1, and RealVisXL to clip 2. The same for the model. Add model merge subtract. Connect CosXL to model 1 and SDXL to model 2. Add model merge add and connect subtract to model 1 and RealVisXL to model 2. Now add the model merge SDXL. Add with model 1 and RealVis with model 2. Connect model merge SDXL with model sampling continuous EDM. Let's understand the crucial model merge SDXL. It has input, middle, and output blocks. Blocks here refer to groups of layers in the neural network, such as input, middle, or hidden and output layers. The values here would be ratios in which each group of blocks is combined. So technically, you can have a ratio of 50% for both inputs. 75% model 1 and 25% model 2 middle layers. And mix 70% of model 1's output with 30% of model 2's output layer. In simple English, the values of each block will make a specific model influence the generation more or less. Let's understand what model 1 is and what model 2 is. Model 1 here is CosXL subtracted SDXL plus RealVisXL. Whereas model 2 is RealVisXL. This is an advanced merge and not a simple merge. So, under no circumstances will you get purely model 1 or 2 output here, as everything is mixed with the input, middle, and output blocks. A value of 1 means the output is more influenced by model 1, and a value of 0 means it is more influenced by model 2. A value of 0.5 means both are equally influencing the generation. You can play around with each value, and the number of combinations is too many to test. Some will break the generation, and some will be stable. To get the most stable output, you only have to modify output blocks 0 to 4. For simplicity's sake, I will assign a single value to all 5 blocks. This means that both models 1 and 2 will have inputs, but the output can be influenced equally or more by anyone. Right-click and convert all 5 output blocks to inputs. Add a float node from ComfyLogic. Connect and rename it as shown. I am going to add 2 switch any nodes. One for the model and one for the clip. The merged model and clip would be input 1, and the CosXL would be input 2 for both switches. After renaming, convert both select values to inputs. Add an impact integer node and connect them. The value can be 1 or 2, rename the node to clarify the same. Change the value of sigma max to 240. This gives you slightly detailed outputs. I have tested and experimented with these values for the output block. Let's understand the formula. Model 1 into ratio plus model 2 into 1 minus the ratio. So a value of 1 would mean model 1 influence, and a value of 0.25 would mean 25% model 1 plus 75% model 2 output influence. I suggest you take a screenshot of this for reference. You can try out all 5 values and check which gives you the best output with your checkpoint. I will be using a value of 0.5 for a balanced output. Add a checkpoint save node. Connect the model and clip outputs as shown. Ensure that the VAE connection is from the CosXL checkpoint. If you hit Q prompt, this will create a folder called checkpoint in the output folder of Comfy and save the merged checkpoint as a safe tensor file. Mute the node for now. The workflow is set up in a way that you can run the generation and test the merged checkpoint. Once satisfied with the model merging, enable this checkpoint save to save the safe tensor. Let's first generate using the base CosXL again. Now change the input to the merged model. Okay, one thing to note here is that the sampler and scheduler should be more aligned toward the real VisXL, or whatever your fine-tuned checkpoint is. For this specific checkpoint, change the sampler to DPM++ 2M. The steps should be around 25 to 35. Reduce the CFG from 8 to 5. You can go as low as 2, but keep 5 as the default. If the image is overburned or oversaturated, reduce the CFG further. These settings cannot be constant. During testing, I usually ended up manipulating the CFG values and steps to get the desired output, so take note of that. When upscaling, there might be a slight color loss. To fix this, you need color match from KJ nodes. Add the node after the upscale output. Connect the input as the image reference and the output as the target. Change the method to HM/MVGDHM, and that's it. This will ensure that there is no loss of color after upscale. Also make sure that you connect this node with the switch in the CosXL edit group. I hope the tutorial was helpful and you learned something new in ComfyUI. Until next time.